We're going to do the Pythagorean theorem. You have done the Pythagorean theorem before at some point in middle school math, either in 7th grade or 8th grade, in all likelihood, but we're going to ramp it up a level. There are several things that you did in junior high math that we do again in this class, but then we take it to the next level. So the Pythagorean theorem itself is pretty simple. It says that in a right triangle, I want you to notice it absolutely positively has to be a right triangle. This does not work if the triangle is not a right triangle. For those of you who take pre-cal, in pre-cal you'll learn there's a rule for if it's not a right triangle. It's actually an extension of the Pythagorean theorem. It has an extra part. But since it involves trigonometry, we're not going to do that. And then the sides are A, B, and C, where C is the longest side. That is the hypotenuse. Then A squared plus B squared is equal to C squared. The sum of the squares of the legs is equal to the square of the hypotenuse. Notice I said the square, not the square root. The sum of the squares of the two legs is equal to the square of the hypotenuse. So, in this triangle, the hypotenuse is x. So that is what goes by itself in the Pythagorean theorem. It would be 10 squared plus 14 squared is equal to x squared. This is part of where knowing your perfect squares comes in handy. 10 squared, I imagine almost everyone knows that. What is it? 100. 14 squared, I heard rainbow. No, 28. No. No, not 128. No.
Wait, 338.
It's 196. It's got to end in 6 because what's 4 times 4? So when you multiply it out, the number at the end has got to be a 6. It's just a question of what are the two numbers before that. Equals x squared. Add these, and we get 296 is x squared. So x is the square root of 296. Now, in middle school math, you would have either left it like that or used a calculator to get a decimal approximation. In geometry, we don't do that. We simplify it to give a simplified exact answer. So this is what you were doing yesterday. So with 296, and I think most of you like doing factor trees, so I will as well. What can we divide that by? Yeah, you can divide it by 2. 2 goes into 2 once. 2 goes into 9 4 times with 1 left over. And 2 goes into 16 8 times. So then what can we divide the 148 by? 4. We always want to divide. 4 won't, or will it? It might. We can try it. I usually do 2 because I can divide by 2 in my head. Dividing by 4, I can't do that in my head. So actually, let's do this by 2. Might as well practice the way we're going to do it. 2 won't go into 1, but it does go into 14 7 times. And 2 goes into 8 4 times. Guess what I can divide by? 2. 2 goes into 7 3 times, but there's going to be 1 left over. So I usually just put a little mark here for the 1 left over. 2 goes into 14 7 times. Now it's a question of Well, what will divide evenly into 37? So before we get started, students sometimes ask, I don't know how many numbers I should check before I should quit. And that's a legitimate question. Okay? 36 is really close to one perfect square. What perfect square is it close to? You got to learn the perfect square, ladies and gentlemen. 36. What's the square root of 36? 6. You only need to check numbers that are smaller than 6. So will 2 divide evenly into it? No. Do you guys know the trick for divisibility by 3? We talked about it.
Add it up and then see if it would go in the 3 family.
Yeah. Add up the digits. 3 plus 7 is 10. 3 won't divide evenly into that, so that's a non-starter. What's the next prime number that's smaller than 6? 4 is not a prime number.
5.
5 is a prime number. Will 5 go evenly into 37? No. So this is a prime number. I can't do any more factoring with it. But what is the square root of 2 times the square root of 2?
2.
2. And I still have a square root of 2 and a square root of 37 left. I can multiply these two together because they're both square roots. And I know what they're multiplied together are. 2 times 37 is 74, because over here I did 74 divided by 2, gave me 37. So this is 2 square roots of 74. Unless the problem says to do it, you don't have to give what that's in between. Just give me a simplified square root. All right, let's do the next one. Which side is the hypotenuse in this one? X. You don't have to write it every time, but you do have to identify which side is the hypotenuse every time. So this will be 5 squared plus 12 squared is equal to x squared. Terrence, you with this? So that's going to be 25 plus 12 squared is 144 is equal to x squared. Add these together, that's 169 is equal to x squared. So x is the square root of 169.
13?
Exactly. It's 13. This is the other reason why you need to know perfect squares, because sometimes it comes out to be a whole number. When those all come out to be whole numbers, that's called a Pythagorean triple. When you have a Pythagorean triple, if you notice it, you don't have to write any work down at all. You can just straight up give me the answer. The simplest Pythagorean triple is 3, 4, and 5. It is the only Pythagorean triple where it's 3 numbers in a row. 3 squared plus 4 squared is equal to 5 squared. So if you get a problem like this, hypotenuse is x, and the legs are 3 and 4, you don't have to write any of this out. You can just write down the answer is 5 and go on. Be sure that it's the legs that are 3 and 4. If one leg is 3 and the hypotenuse is 4, the other leg's not going to be 5. It doesn't work that way. You can also do any multiple of that. So like if I doubled these, what would I get?
6, 8, and 10.
Yeah, 6, 8, and 10. Or you could triple them or quadruple them. You could multiply them both by, all by 10. Any of those things would be a Pythagorean triple still. I think that you should memorize 3, 4, 5. It will save you some time. It comes up often enough to where I think it's worth memorizing. Now, I told my honors geometry class this morning. When I was in elementary school, back while the world was still cooling, man, nobody gets the, oh, somebody got the joke, thank you. When you do your multiplication tables, right, and you have to memorize all those, I didn't memorize them. Instead, I just learned to add fast. Okay, so like if I had to multiply 6 times 8, I would do 6 and 6 is 12, 12 and 12 is 24, 24 and 24 is 48, done. Okay, which made me good at adding, but it was kind of dumb. And when I was your age, I was a sophomore in high school, and I was doing an algebra 2 problem, and I had 6 times 8, and I'm doing that, and this little voice in the back of my head goes, "Hey, stupid, you should probably just memorize that now." And the little voice in the back of my head was right. At some point, when you see something often enough and you're having to work it out every single time, you just memorize it. Okay? I think it's worth it to memorize 3, 4, 5 and know that if I double it or triple it or whatever. And the other one that comes up is this one that we just did, 5, 12, 13. And if you double that, 10, 24, 26, you can see that if you were actually doing these numbers real quickly, you don't want to be squaring and having to take the square roots of these kinds of numbers because they're going to be so large. Okay? There are an infinite number of Pythagorean triples. How many do I think you should memorize? These 2. They come up often enough, and they come up on things like the SAT. Yes?
There's one right under that question.
I'm sorry?
There's one right under the question, 6, 10, and 8.
Yeah, I wrote it down right here. Yes.
Look at the example under that triangle.
Yeah, I'm fully aware of what the examples that I have chosen for today are. Okay? So 3, 4, 5, 5, 12, 13. You should memorize those. It just makes life easier. All right. Now, on these, the hypotenuse is a number instead of being the variable. So we'll take the 2 legs, 12 and x, square them and add them together. And that'll be equal to 16 squared. 12 squared is 144. 16 squared .
256.
Yep, 256. Very good. On this one, instead of adding, we're going to have to subtract. Subtract 144 from both sides. And we get that x squared is 112. And then we need to divide this up. So with 112, what's a number that, how can I divide this up?
Can you do 4?
4 will go into it evenly. 11 will not divide into 112. It divides into 121. 4 goes into but see, again, the problem I have with doing 4 is I've got to branch off and do this because I can't do it in my head. Actually, I can, but it'd be 28. And then the 4, we can divide that in 2 and 2, and 2 and 14. Here we'll have 2 and 7. So x is equal to the square root of 2 times the square root of 2 is 2. This square root of 2 times the square root of 2 is another 2. And what do I have still left? Which is still a square root, right? So this is x is 4 square roots of 7. For this one, the 10 is the hypotenuse. If we set this up, we'll have 6 squared plus x squared is equal to 10 squared. And if you remember it, you can go, oh, hey, that's a 6, 8, 10 triangle. I don't have to do all the work. I can just skip straight to the answer is x is 8. It's one of our Pythagorean triples. If the hypotenuse is 10 and one of the legs is 6, the other leg is 8. All right, so other than simplifying, all of that is junior high stuff. Now let's go beyond that. If you'll turn the page. So in a triangle with sides of length A, B, and C, where C is the longest side, there are 3 possibilities. The first possibility is that C squared is equal to A squared plus B squared. Well, that's the Pythagorean theorem. And what does Pythagorean theorem only apply to?
If it's right.
Right triangles. Only applies to right triangles. So that means it's got to be a right triangle. On the other hand, if C squared is bigger than A squared plus B squared, well, that means that the big side is too big. So think about this for just a second. You don't need to draw this, but please look up here. So if I start off with a right triangle, if I left this side and this side the same length, but I made this side bigger, what's going to happen to the right angle if I make this side bigger?
It's not going to be right anymore.
Well, it's not going to be right anymore. What's it going to do? Is it going to get bigger or smaller?
Smaller. That's bigger.
I have a vote for bigger and a vote for smaller from the same person.
I'm going to stay with bigger.
If this side gets bigger, right, it's going to have to make that other side open out. So now if this side had gotten bigger, this angle has opened up, and it's now what kind of a triangle?
Obtuse.
Obtuse. If C squared is bigger than A squared plus B squared, the triangle is obtuse. And if C squared is smaller than A squared plus B squared, now this angle got smaller, and so it's an acute triangle. So the way to think about it is the Goldilocks principle. Everyone familiar with the story of Goldilocks? So if the big side is too big, it's obtuse. If the big side is too small, it's acute. And if the big side is just right, it's a right triangle. It's dumb, I know. Okay? I fully get it, but if that helps you remember it, I'll do dumb things all day long. Okay? So, given the sides of a triangle, determine if the triangle is acute, right, or obtuse. So, I personally, on this, I start with C. I know that's the opposite order of the way we normally write the Pythagorean theorem, but I want to know, is the big side too big, too small, or just right? So the biggest side is 13. And I'm going to compare that, so I'm going to put a question mark right here, to 8 squared plus 11 squared. The order over here is not important. 13 squared is 169. 8 squared is 64. And 11 squared? 121. So I've got 169 and 185. The big side is too small. Small. Acute. Right? Smaller than 90. That's why I like to do it in this order.
I have a quick question. Is it like the difference between the smaller one needs to be 90 degrees or like I'm just
Say that again.
Okay, so if it's 90 degrees, doesn't that make it like right? And then if it's bigger than 90, it's obtuse?
Yes.
Then how did we get acute?
This is less than.
Oh, like the difference in between needs to be
No,
right.
no. These are all sides.
Okay.
There's no 90 in this directly. But what we're saying is we have a triangle whose big side is too small for it to be a right triangle.
Okay.
So if you start off with a right triangle and you make this side smaller, right? If you shrink this, the only way you can shrink that is if you pull this other side in some. So it's no longer a right triangle, it's now an acute triangle.
Okay.
So if the big side is too small, the triangle is acute. Okay? All right, for this one, what side am I going to start with? 14. 14 squared compared to 6 squared plus 9 squared. 14 squared? 196 compared to 36 plus 81. So that's 196 and 117. 196 is greater than 117. The big side is too big. So this is obtuse. All right, let's take a look at this one. It's a little bit tricky. Not terribly, but a little bit. Because people are like, well, which one of those is the biggest? Is the square root of 11 the biggest, or is 4 the biggest? Well, there's a real easy way to tell. What is 4 the square root of? 16. So if I'm comparing the square root of 5, the square root of 11, and the square root of 16, which one is the biggest? Square root of 16, so 4 is the biggest. So I'm going to compare 4 squared to the square root of 5 squared plus the square root of 11 squared. Well, we've already done 4. 4 squared is 16. The square root of 5 squared, that means the square root of 5 times the square root of 5. What is the square root of 5 times the square root of 5? It's 5. Plus, the square root of 11 squared is 11. This one's just right, so it is a right triangle. All right, let's take a look at this one. What side should we start with? 12. 12 squared compared to 6 squared plus 8 squared. 12 squared is? 144. 6 squared is? 36. 8 squared is? 64. This is going to be 144, and this is only 100. So the big side is? Answer my question. The big side is too big. So this is what kind of triangle? Obtuse. All right. Okay, I have a worksheet for you